All right, so we spent all this time and energy building these incredible AI models, right? But what actually happens the second they go live? Today, we're going to pull back the curtain on the unseen life of AI after it's been deployed. And you'll see why keeping a close watch on it isn't just, a nice to have. It's literally the only thing that stands between a successful model and a total silent failure.
Okay, so picture this. You've spent months, maybe even years, building the perfect model. It's smart, it's fast, and finally, you hit that deploy button. The team celebrates, you pop the champagne, job's done. Time to move on to the next project, right?
Yeah, not even close. And this quote right here, it just hits the nail on the head. See, getting a model out the door, that's just the starting line. The real challenge, the absolute marathon, is making sure it stays accurate and useful when it's out there in the messy, unpredictable real world. And that's exactly what we're going to dig into. Because here's the thing. The moment your shiny new model hits the real world, it starts to age. It begins to degrade. This is the story of when good models go bad. And the scary part? It's often a silent decay, happening right under your nose without you even realizing it.
So let's meet the main culprits here, the villains that cause this decay. First up, you've got something called data drift. This is when the data the model sees in the wild starts looking different from the data it was trained on. Then you have concept drift, which is even sneakier. That's when the meaning of what you're trying to predict actually changes. Both of these lead to model staleness. Basically, the model's knowledge gets old and crusty, usually because of how people, user behavior, have changed.
So let's make data drift super clear. Imagine you build a recommendation engine, and you train it on data where your average user is, say, 35 years old. But then, a year later, your app totally blows up with an older crowd, and now your average user is 52. All of a sudden, your model is living in a world it was never trained for. Its basic assumptions are just broken, and its performance? It's absolutely going to take a nosedive.
Now, concept drift, this one's even sneakier. Let's say your model is a rock star at detecting a specific type of fraud. We'll call it fraud type A. But guess what? The fraudsters get smart. They adapt. They invent a whole new method, fraud type B. Now your model? It's like a perfect security guard staring intently at the wrong door, completely useless because the very idea of what it's supposed to be looking for has changed.
Okay, so how on earth do we fight back against this silent decay? Well, we give our AI a continuous health check. We set up a monitoring system that basically watches its every move 24/7.
And this is what we call performance monitoring. Honestly, the best way to think about it is like a guardian that never ever sleeps. It's a system that's constantly tracking the model's vital signs out in the real world, making sure it stays accurate, fast, and most importantly, trustworthy.
So what are these vital signs we're actually watching? Well, it really boils down to three key things. First up is accuracy. Is the model still getting things right? Then there's latency. Is it still fast enough to be useful? And finally, we're looking at errors. Is the whole system stable, or is it starting to crack under pressure?
A drop in accuracy is like the classic red flag. Look at this chart. Just last week, this model was humming along at 96.1% accuracy. Awesome. But today, it's dipped down to 92.4%. Now, that drop isn't just some number on a dashboard. It's a huge warning sign that the model's performance is degrading, and we need to do something about it fast.
Next up is speed, or what we call latency. And this is so important because a brilliant 100% accurate prediction is completely useless if it shows up too late. For most apps that you use in real time, anything over 200 milliseconds just feels slow. And when you're working at a massive scale, that little bit of sluggishness doesn't just create a bad user experience, it can actually cause a domino effect and threaten the whole system's stability. And finally, we track errors. But here's the thing. The most dangerous kind of error isn't some big, obvious system crash. No way. The most dangerous threat is the silent failure. It's the model that looks like it's working just fine, but behind the scenes it's making bad decisions over and over again, quietly draining money, wasting time, and eroding trust. But look, just watching these metrics isn't enough. Monitoring is pretty pointless if you don't do anything about it. This is where the real power of modern AI operations, what we call MLOps, comes into play. It's all about turning those alerts into immediate, automated action. This is where MLOps gets really cool. It's all about building smart, automated systems around your models. We set up these triggers, right? So if latency suddenly spikes past 300 milliseconds, boom, an alert goes out. If accuracy drops by more than 5%, it automatically kicks off a retraining process with new data.
It's really like building an immune system for your AI.
And all this automation creates this incredible continuous learning loop. You monitor the model out in the wild, you detect when it starts to slip, you automatically trigger a retraining, and then you redeploy the newly improved model. And a lot of the time, this happens with zero human intervention. It completely transforms your model from just a static piece of code into a living, breathing system that's always learning and adapting.
So, what all this really points to is a fundamental shift in how we need to think about AI. Deploying a model isn't the finish line. Not at all. It's the starting gun. It's the beginning of a long-term commitment, where you become a forever guardian for that model.
So what are the golden rules here? What should you take away from all this? Rule number 1, and this is non-negotiable, never deploy without monitoring. Don't fly blind. From there, you've got to automate your alerts, you have to track both accuracy and latency, you need to be actively looking for drift, and you have to build those feedback loops. I mean, this isn't just about good process. It's the fundamental difference between a cool science project and a professional, reliable AI system that people can actually depend on.
Look, if you remember just one thing from this whole explainer, let it be this. Deployment is temporary. It's a single moment in time. But monitoring is forever. Building the model, that's the sprint. Keeping it healthy and effective in the real world, that's the marathon.
And that leaves us with a really important question to think about. Consider all the AI systems that are making decisions that affect our lives every single day. You know, from what medical treatment you get to whether you're approved for a loan. Are they being watched? Are they being monitored? Because an AI that's left unchecked isn't just a technical problem, it's a massive breach of trust.